Okay, Geometry 4.4, Congruence and Transformations. If we look down here, um, there's two special things that we need to know, and you want to come back to these when we get to those types of problems, when you see these types of problems. Um, and it's pretty simple what happens here, so just a quick explanation. Um, the distance between your two parallel lines is called d, and so the distance from your preimage all the way to your image is 2d. That's what that's saying. It's double that distance. So the distance in between the two parallel lines, if you double it, that will give you the distance all the way from A to A prime. And the same thing as far as your angles are concerned. So this degree of angle is called x, okay? And so the whole degree is double that, and that's where they're getting the 2x. So when we get to those, you might want to come back and take a look at this. Okay, so first of all, how do you know that figures are congruent? They have to have the exact same angles and the exact same distances between points. So they're not trying to trick you here. It's just obvious what they are. So what we're going to do is label triangle JHK, and you got to make sure you have the right order here. So J goes to H, which is the 90-degree angle, and then to K. So if we look at R and Q and S, you better start with R, then to Q, and then to S. Okay, so those two are congruent. 1, 2, 3, 1, 2, 3 for those lengths, and the height is 1 for both of those. So you have to check all that stuff. These two I think are obvious, but they are not the same. The slope here is not the same as that slope. But then you have these two in the middle here. Just check that your distances are the same, and then you can go ahead and say that rectangle MNPL. Make sure you go in a consistent direction, and we're going to say that's congruent to rectangle EFGD. Okay, because you want to line up each letter with the correct corresponding position. That's what you want to do. Okay, so we have to do quite a few transformations here, two really. If you reflect in the y-axis, this will put your picture over here, okay, and A prime's over there. And then we reflect over the x-axis, all right, and that would put it down here. And notice it's not quite in the right spot. If you just said reflect over the x-axis this way, the distance here is 1, the distance here is 2. Or if you translated, okay? If we translated, that's fine. We're going to translate here. Okay, so now you have it like this. Now it needs to translate. Okay, and we're going to go down 1. All right, so if we wrote a rule, y is going down 1, and then to the right, 1, 2, 3, 4, 5. So, or to the left, sorry, to the left 5, minus 5. And you'll get it doing 3 of those. There's different ways you can go about doing it, so just try a few things to get it, because you have to typically do this on your exam or your quiz somehow. Okay, determine whether the polygons are congruent. So here you have to actually graph them. So we're going to graph and see what happens. So the first one, Q is at 2, 4. R is at 5, 4. And S is at 4, 1. All right. Okay, and then T is at 6, 4. We'll do this in blue. That's T. And 9, 4 is U. Okay. And V is at 8, 1. All right, now the question is, are those the same? Well, let's count distances here. 1, 2, 3. 1, 2, 3. So those distances are the same. And then how you do distances diagonally is using slope. which is a vector. All right, so like QS, what is that vector? So we go down 1, 2, 3, and over 2. Okay, so vector 2 and negative 3, down 3 and over 2. Remember, it's backwards. And then TV, we go down 1, 2, 3, and over 2. Okay, again, the same thing. And then you got to check RS. So you don't have to write these down. You just have to check them. So we go down 3 and over 1. So left 1 and down 3. And then you check UV. So that goes down 3 and over 1. Okay, so make sure you put it in the right positions. Remember, run is first and then rise. All right, next one. Same thing. Let's go ahead and graph these. J is at 1, 1. K is at 3, 2. And L is at 4, 1. So we have J, K, L. All right. And now we do M is at 6, 1. N is at 5, 2. And P is at 2, 1. Oh, wow, we need to do these in blue. Now it's a little harder to see, but we can count this time. So let's count J to L, 1, 2, 3. And P to M, 1, 2, 3, 4. There, that's wrong. So JL was 3, and PM was 4. Okay, so right off the bat, we know they're not the same. All right, reflection. Now, remember what I said at the beginning. This distance, D, is half of that distance. That distance is 2D. All right, so whatever, you're going by the distance from K to M here. All right, so now, if the distance between K and M, all right, in this case D, is 2.6, what is the length of C to C double prime? Okay, again, anywhere from the preimage to the image is twice whatever D is. So C to C double prime, distance without anything on top here, that is going to be 5.2. Just double it. Same thing with your curves here. Again, if the interior angle is 55, then going from the preimage all the way to the image is double that. All right, so let's see what it says. Yeah, A to A double prime. So the angle from A to A double prime, now that degree, so this degree right there, is going to be 110 degrees. That's definitely on the test. Make sure you can do these. All right, now what did they do wrong here? So first of all, what is the degree from P, or from the blue image, all the way to the green image? Well, if the interior angle is 72, then double reflection gives us 144 degrees. So let's see what they did. All right, a 72-degree rotation about point P maps the blue image to the green image. Okay, so we already did that. Good, 144 degrees. Okay, so we're mapping C to C prime over two reflections. Now, I don't like this because what we've been doing is saying, hey, how do you get from C to C double prime? So that means C prime must be here. But that's not what it's saying, okay? What it's saying, let's erase those things here. What it's saying is there's two reflections to get from C to C prime. All right, so the total rotation from C to C prime is 84 degrees. So what is the interior angle? 42 degrees. All right, so be very careful. If it says you've made two reflections and the total degree is 84, you got to divide it by 2. Okay, now, find the measure of the acute or right angle formed by intersecting lines so that C can be mapped to C prime using two reflections. Okay, so this is the rotation of what happens. This is the rule. So what this is showing you is that you're changing the sign on X and Y, both. Well, that's a 180-degree rotation. Okay, so again, if you didn't know this, which I told you don't have to know, I'm not going to give it to you like this on the quiz or anything. If you didn't know this, you'd have to look it up, and that's 180-degree rotation. And I'm not going to have you mess with that. But anyway, if it's two reflections and it's 180 degrees total, then your intersection, okay, so the interior angle must have been 90 degrees. So it's asking for the interior angle. All right, now, this is important. We usually ask an always, sometimes, or never type of problem. So let's make sure we understand these two. A congruence transformation changes the size of a figure. Okay, now, this is a congruence transformation. Congruence means it stays the same size. Okay, this is only sometimes. Okay, because you have, let's just write it out here, translation, you have, we did reflection, and then we did rotation. Okay, so those are all what we call rigid. They don't change the size. And then we did dilation. Okay, so what we're trying to have you understand is that all of these are transformations. Dilation changes your size. Okay, so they're saying congruence transformation changes the size of the figure. Okay, well, that's only sometimes, and that's only if it's a dilation. And if you're only talking about these three here, then it's never. Okay, but a transformation, all of these are under the umbrella of transformation. These are all transformations. And dilation changes your size. So out of those four, it's only sometimes. This one, the composition of two reflections results in a rotation. Okay, is that always or only sometimes? Okay, so if we have this line right here, and we reflect it over the x-axis, it's going to be right there. And we reflect over the y-axis, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And that's what we have right there. Okay, so it's 3 units long. If we rotated the original figure, okay, if we rotated this figure right here, to get to the two more quadrants, that's 180 degrees. So is that what you get? And the answer is yes. It's always. All right, solve the equation. All of these, so 36, 12 plus 6m equals 2m. So we got to get our m's together. I'm going to subtract 6m. So 12 equals negative 4m. Don't forget the equal sign. I'm going to divide by negative 4. Don't forget the equal sign. So m is equal to negative 3. Number 37 is negative 2 times 8 minus y equals negative 6y. So we need to distribute. Negative 16 plus 2y equals negative 6y. Now let's subtract 2y from both sides. Again, don't forget your equal sign. That's negative 8y equals negative 16. Now we divide by negative 8. We get 2 equals y. Okay? And 38. 7 times 2n plus 1 equals 1/3 times 6n minus 15. Now, I know most of you are going to distribute, so we'll go ahead and distribute. 14n plus 7 equals 1/3 of 6 is 2, or 6 divided by 3. Remember, if the top's a 1, you can just divide by the bottom. 6 divided by 3 is 2, and 15 divided by 3 is 5. Okay, so now we need to subtract 2n. We get 12n plus 7. Don't forget your equal sign. Equals negative 5. Don't drop that minus sign either. That's still attached to the 5. So now we subtract 7. Okay, and we get 12n equals negative 12. Now we divide off the 12. And n equals negative 1. Okay? And the last problem here. Find the value of x. And show your steps. Okay, well, those are equal. They're alternate interior angles. Okay, so 6x equals 48. Divide off the 6, x equals 8. It says show your steps, so make sure you show your work. And these two are on the same side of the transversal, so they are consecutive exterior angles. Okay, so consecutive interior or exterior means you add them together and set them equal to 180 degrees. So you have to remember all this stuff. So these two go together, they're on the same side, so we just add them together. That's 132 equals 180. Now we subtract 132. Again, you have to show your work. Don't forget your equal sign. So 12x is equal to 48. And divide off the 12, and x is equal to 4. So those are your answers for 49 and 50. Good job.